Hello everyone, this is Pushparao Iragattapu. Welcome to my channel JSN Chemistry. In this video, I am going to discuss about the another name of vitamin C, that is ascorbic acid. Ascorbic acid. Actually, as far as we know in organic chemistry, any compound that we call it as an acid, generally those compounds contain functional group that is acid functional group COOH or C double bond OH. So when we are calling vitamin C as a ascorbic acid, we also think that this vitamin C might have carboxylic acid functional group that is C double bond OH. But here if you see, if you look at the structure of vitamin C, it doesn't have any acid functional group that is C double bond OH. Of course, we have C double bond O and we have OH, but this OH is not attached to that C double bond. I mean, this OH is not attached to the carbonyl carbon of that C double bond. So this is not an acid functional group. This is C double bond O functional group, which is part of ester, part of an ester, and this is OH functional group. But still, why we are calling it as ascorbic acid? I mean, why vitamin C called as an acid? What would be the reason? So that reason now we are going to learn. Actually, any carboxylic acid that you take, here I am taking the general formula of carboxylic acid, that is RC double bond OH. This carboxylic acid continuously undergoes one thing, that is intramolecular proton transfer. Intramolecular proton transfer. Intramolecular proton transfer. Continuously it undergoes one thing. From where to where it undergoes? Actually, here if you see C double bond OH we have, right? We know oxygen is more electronegative than the carbon. So because of that, these pi bond electrons will be shifted towards oxygen. While these pi bond electrons are shifted towards oxygen, at carbonyl carbon we will get the partially positive charge. For nullifying that, this oxygen will push its lone pair of electrons towards that. So because of this, we will get the resonance structure like this: R C double bond O minus double bond OH plus. Since oxygen contains positive charge, so it will lose its proton. That proton will be captured by your O minus. And this is how the proton gets transferred from one oxygen to the another oxygen. So this is what happens in any carboxylic acid compound. Now here in vitamin C also, if you see, if you look at the vitamin C also, same thing happens. This intramolecular proton transfer happens, though there is no C double bond OH functional group. I mean, though there is no carboxylic acid functional group, but still this intramolecular proton transferring is happening from one oxygen to the another oxygen, like this. When this lone pair of electrons are shifted towards this CO bond, these pi bond electrons will be shifted towards adjacent CC bond. Because of that, these pi bond electrons will be shifted towards oxygen. So when these things happen, this oxygen gets partially negative, complete negative charge, and this oxygen get the partial, positive charge. So because of that, this proton will be lost, and this proton will be transferred from this oxygen to that. And because of this, I'm not writing full structure here. I'm writing some rough skeleton. And this is what we get. So the thing which is happening in the carboxylic acid functional group, same thing is happening here also. I mean, that is intramolecular transfer. So it is also behaving like an acid. So that's why we are calling vitamin C as acid, though there is no functional group. I hope you have understood this question, this content. If you have understood this content, please subscribe my channel. Thank you.